So chapter 10, this will be chapter 9 in the older editions. Theories are nets cast to catch what we call the world. To rationalize, to explain, and to master it, we endeavor to make the mesh ever finer and finer. Interesting quote from Karl Popper. In this chapter, we're going to be talking about chemical bonding. There are two chapters talking about chemical bonding. In this one, we're going to talk about the Lewis model. There's different bonding models. We're going to start with one of the simpler ones. So, why do we even care about bonding models? Because they help us to discover new things, new useful things, in a more efficient way. So an example of this has to do with AIDS research. In 1989, the AIDS epidemic was still relatively new and we didn't know much about it. There wasn't much treatment available. In 1989, the structure of Hiv protease was determined. So protease is an enzyme. It's a protein that is synthesized by HIV. And so once they knew the structure of that enzyme, they were able to design several molecules that would disable the enzyme by blocking binding to its active site. So it's like, the enzymes are often referred to as being a bit like a lock on a door, and you have to have the right, I'm just blanking on everything, substrate to activate the enzyme. You have to have the right key to open the door. And so what this was doing is finding some molecules that would fit into the keyhole and keep the substrates from going in there and activating the enzyme, but wouldn't actually activate the enzyme themselves. So blocking it so it couldn't work anymore. Bonding theories were used to help sort out what drugs might work for this by looking at the shapes of them and how they interact with their neighbors. So protease inhibitors are actually very effective. They don't cure HIV, but they can reduce the levels so low that they can't even be detected. You keep taking the inhibitor and you're fine. You stop taking it, not so much. So bonding models in general are going to explain how the atoms bond together to form molecules. We haven't talked about this at all, really. Why are some molecules stable and others are not stable? Bonding models help us understand. They also help us to predict the shapes of molecules, and the shape of a molecule often has a big effect on its chemical and physical properties. So there's several different models, and they are all useful. There's, as often is the case, a trade-off between predictive power and complexity. So the more advanced theories allow us to predict a lot more things and have fewer exceptions, but they are also much more complex and harder to understand. So we're going to start with a simpler model. Doesn't work for everything, but it works for a lot of stuff, and that's good enough a lot of the time. So this is the Lewis model. In the Lewis model, the valence electrons are represented as dots. And so we draw structures, and they're called Lewis dot structures or Lewis electron dot structures. And so we're representing the electrons as dots. And this is all about the valence electrons. It's the simplest model, and it gives us prediction about shapes and helps us to understand if a molecule is likely to be stable.